This video is meant for Mrs. Rose's AB Calculus class, and our topic today is implicit differentiation. So implicit differentiation is only really useful for differentiating expressions that are not functions. So I'm talking about circles, ellipses, hyperbolas, expressions that fail the vertical line test. When we're starting to take the derivative, all the rules that we've already learned about derivatives apply. So when we're taking the derivative of x squared plus y cubed equals 6, we're going to use power rule. So we're going to have the derivative 2x, stick with me on this one, dx over dx, plus 3y squared dy dx equals 0. The idea here is we're going to take the derivative of everything with respect to x, whatever the variable that I've asked you to take the derivative with respect to. So when we take the derivative of x squared, it's 2x, but then you have to multiply by the derivative of x. Think of it like chain rule, where you have an inside function and an outside function. So we've taken down the 2, we have x to the 1 power, that's in parentheses. So then we have to multiply by the derivative of the inside. Well, the derivative of x is derivative of x over derivative with respect to x. Y, on the other hand, we bring down the 3, we subtract 1 from the exponent, but the derivative of y with respect to x is dy dx. So here, the next thing we're going to do is we're going to move the 2x to the other side. The reason why my dx over dx goes away is because I have basically 1 right here. This is 2x times 1. And I'm subtracting that to the right side of the equation. And then I am going to further isolate dy dx by dividing both sides by 3y squared. So our derivative of this expression is dy dx equals negative 2x divided by 3y squared. So our second, step would be isolating dy dx. For this one, we're going to use product rule because it's t times s squared. So we're going to take the derivative of t with respect to t times the second function s squared plus t times the derivative of s squared, which is 2s ds dt. It's with respect to t, and that equals 0 because the derivative of 4 is 0. Now our goal is to isolate ds dt, dt equals 1. So I'm going to have s squared plus 2ts ds dt equals 0, and then I'm going to subtract s squared from both sides. To further isolate ds dt, I'm going to divide both sides by 2ts, and then s squared divided by s is going to be negative s in the numerator divided by 2t. For this third example, we're taking the derivative with respect to x. So the derivative of w squared is going to be 2w times dw dw plus 2y times dy dw, and the derivative of 25 is 0. dw over dw is 1, so we have 2w plus 2y dw dy dw equals 0, and then we're going to subtract 2w and then divide both sides by 2y. Then I'm going to simplify to get dy dw equals negative w divided by y. In this example, we're taking the derivative with respect to x, so the derivative of x squared is 2x dx dx plus 8y dy dx, derivative of 4 is 0. Again, I'm bringing the 2 down, multiplying by 4 to get 8y times the derivative of y with respect to x. dx over dx is 1, so we get 2x, or rather I skipped a step, negative 2x on the right-hand side, dy dx, divide both sides by 8y, simplify both sides, and our derivative is dy over dx equals negative x over 4y. For our last example, the right side's going to use chain rule. The left side's going to use chain rule, and the right side's going to use product rule. So, to start off, we're going to multiply the 2 times the 3 to be 6. The parentheses is the same to the 1 power times the derivative of the inside. So I'm going to have 2x dx dx plus 2y dy dx, and then I'm going to have an equal sign. And here I'm going to use the 100x as one equation and y as my second one. So my derivative is going to be 100x dx dx times y plus 100x times the derivative of y is dy dx. Now we want to get the dy dx's together and isolated, so I'm going to distribute my 6x squared plus y squared into this parentheses here. So I'm going to multiply all of this times the first term and the second term in the parentheses. So I'm going to get 6 times x squared plus y squared times 2x plus 2y dy dx. Oh, just kidding. All I did was made the dx over dx 1. Now I'm going to distribute. So I'm going to have 12x times x squared plus y squared plus 12y x squared plus y squared dy dx equals 100y plus 100x dy dx. Alright, now what I want to do is move everything that has a dy dx to one side of the equation and everything that doesn't have a dy dx to the right side of the equation. Okay, this side stays on the left, so it's positive. This side moves to the left, so it's negative. This stays on the right, so it's positive. This moves to the right, so it's negative. From here, we're going to isolate dy dx by taking the greatest common factor out of these two things. So we've got 12y x squared plus y squared minus 100x times dy dx equals the right-hand side. And then we are going to isolate dy dx by dividing both sides by your bracket. And that's it. If you have any questions, please come to Cal Morning or ask me during class. Have a good night.